So as you can see here, the two cell I have defined the weight of the vehicle, and then you will ask me why you have defined two types of the weight. And the reason is very simple. So I'm just going to describe you the two scenario. Let's say the vehicle is completely loaded with the passenger and the goods, and then you are trying to climb on the hills. So during that time, the torque requirement has to be calculated on the gross weight. But in the second scenario, when people measure the acceleration, let's say 0 to 100 kmph in 8 seconds, or 0 to let's say 60 kmph in 6 seconds. So in that case, they do not go with the gross weight, they go with the curve weight plus one driver, and that's what they define those number. So for the max torque calculations, I will be using the gross weight, which is equal to the vehicle weight plus the all passenger weight plus the all the goods that we can put inside the trunk. So that will be the gross weight. For the acceleration performance calculation, we will be using this weight, which is the curve weight plus the driver weight. But here I have put the same number in both, but you are free to modify this one. Now the next cell, which is the frontal area, the unit is meter square. I have taken here 2.5. The next cell, the drag coefficients. Now the next one is the wheel radius. Here the rolling resistance coefficients that I have given as a 0.015. This is all you can edit as per your requirement. The next parameter, which is the gear ratio, and then the efficiency of the gear. And the next parameter, what we have defined here, the acceleration due to gravity, and the next one, which is the air density. So this is the vehicle parameter. In this area we have defined it. This I will come later about this input, but let's go directly to the vehicle performance specs. So what is the maximum speed that we want to go with my vehicle that I'm going to design? And if you see in India, the max speed will somewhere vary from 100 to 150 or 180 kmph. I have taken 110 kmph. Now coming to the acceleration performance, here I have taken 0 to 60 kmph in 8 seconds. That's what we want in our vehicle. Now the for max torque, or the next vehicle performance that we want, the mountain climbing. So I have taken here the inclination of the road or the mountain road is 12.4 degree. The climbing distance is 20 meter, and the climbing time to climb is 12 seconds. And let me explain you in a more details what I mean by this three parameter. Let's say we are here at the bottom of the hill. So our car is here and it's ready to now climb on the road which has inclination of 12.4 degree. And then after climbing, then it will be again the flat. So what I want, this completely loaded vehicle should climb, but in what second? I don't want to climb in a one day here to here, so there should be a predefined time. And what is the distance of this inclinations? So generally on a typical, it you will find this would be somewhere around 20 to 30 meter, and that's what I have taken here, 20 meter. And time to climb this distance, which is 20 meter, I have taken 12 second here. So let's say you want to climb in 4 seconds, the torque requirement will be very high. Or let's say you want to climb in 1 hour, then torque requirement will be very less. So that is how you can play with this parameter over here. But here I have taken the road inclination 12.4 degree, climb to distance, which is here to here is 20 meter, and then time to climb is 12 seconds. So we are done with this input. The next, which is the continuous mode of operation, where relatively higher torque required in a continuous mode of operations, and that is when you are going on the hilly road which has a continuous gradient of 5 degree, and then cruising at the constant speed which is 60 kmph that I have taken. So you are free to input any value which you wish, but I have taken these sets of value here. Now the next set of input that you see for EV range input, or input for calculating the range of the electric vehicle, and here this area you see the input for drive cycle, and I'm going to come later to explain about these two areas. So at this point, the most important input that we have is the vehicle parameter and the vehicle performance. When we are done with putting all the values in a automation mode, what you have to do, you have to just click the calculate button, and then you will get all the result in a dashboard and the data. But this all tutorial is all about understanding the concept, and the understanding comes from doing each and every calculation using hand, and that's what I'm going to explain next. So with this set of inputs, which is the vehicle parameter and the vehicle performance specs, let's calculate the motor that can support this vehicle performance specs.